Good day everyone, welcome to the course on biological data analysis and visualization with R. In this class we will be talking about basic functions in R. So in the earlier classes we have introduced R, we have talked about how to install packages, we have looked into basic operators in R. So we will build on that and in this class we will be talking about basic programming in R, right, how we can program. So some of you might be familiar with other programming languages. Here we will talk about very basic programming because some of these might be useful for us, and then we will talk about statistical distribution. So this is something that forms the basis of all the statistical tests and analysis in R, right. So these are the two topics that we will be talking in this class, basic programming and statistical distributions. So we have talked about some of the basic operations earlier, right. For example, we have talked about assignment operators, mathematical functions, etc., relational operators, right, greater than, less than, etc. So there is another type of operation we have, and that's part of the programming in R, is the logical operators, right. So we have this ampersand sign or double ampersand sign, these are the logical AND. They are not exactly same, there is slight difference. So for example, the single ampersand sign will evaluate each element separately and you will get an output, that's a vector that will actually have the same number of elements as the number of elements in your data structure. Whereas double ampersand sign will give you only single output, whether true or false. Okay, so that's it. So that's why it's logical AND. Similarly, we have again logical OR, we have single slash or double slash, right. So these are the logical OR signs and we use them in programming. Okay, so with that we can now move into very basic programming in R. Again, I will show you how we can implement this, very simple programs, but as you can imagine you can build on many more complex, right, programs, but the structure remains the same. So you can combine all these elements together now, mathematical functions, statistical tests, etc., and you can build very complex programs. So the basic programming in our functions that we'll talk about is the if-else statement. Okay, so you have these if functions, right, so we can look into these if-else statements. We have for and while loops. So I'll again illustrate with very simple example how do these loops work, right, how do these functions for while work, and these are very similar to again some of the other programming languages that might be familiar with, like Python or C, C++, etc. I'll also talk about how you can define your own function, right. So for example, you want to define a function to do some statistical tests, right. So for a large data set, maybe you want to process the data, then you want to define a function that will actually do some tests, it will then generate some plot, etc. And maybe if you want to do this for multiple data points or samples, you want to write a function and just call that function from outside, okay, outside that function. Okay, I'll illustrate. Maybe these some of those who are familiar with functions in other programming languages, it's probably clear, but those who are not, right, I'll illustrate for you, right, how you define function and how do you call function from outside. Okay, so this is something again part of the hands-on, right. So we'll talk about this basic programming, we'll talk about this logical AND, logical OR, I'll show you in the hands-on part. Then I'll talk about the statistical distributions part, right. So this is something that forms the base of statistical techniques in R, right. So you have these distributions that are defined in R, right. So here just I have written down like 4 very popular probability distribution functions, right. So you have binomial distribution, Poisson distribution, and normal distribution, and uniform distribution, right. So you have many more distributions, you can define many of those, you have a lot of distributions, etc. in there. What I'm going to show you, right, is how you actually extract information or how do you use these distributions in your analysis, right. So if you want to use them for certain purpose. So for doing that, you have specific functions for each of these distributions, and for each distribution you have these 4 sets of functions. Okay, for binomial distribution is the binom function, but in front you have this R binom, right? So you have these 4 letters that you will see, and they denote 4 different things. Okay, so you have R binom, you have D binom, P binom, and Q binom. Okay, so these are the R, how you actually access the binomial distribution, right? So R binom, right? So we use, if you want to generate a binomially distributed random values, right? If you want to generate a set of values that's binomially distributed. Okay, so that's when we will use this R binom function. The D binom function that we have, it's a probability density function, right? So it will tell you what is the probability density. Then you have the P binom, which is the cumulative distribution, right? So you get a value, right? So you get a value, you want to know the cumulative distribution function. And then you have the Q binom, which is the quantile value, right? So if you want to know the value of a quantile, you will use the Q binom function. Okay, so we have these 4 functions that, so I have explained them with respect to the binomial distribution, but these functions are present for all distributions that we'll talk about, right? So similar notations here, so you can see, right? So you have R binom, D binom, P binom, and Q binom for binomial distribution. Similarly, you have the similar functions for Poisson distribution. Similarly, you have for normal distribution. So I'll illustrate them with normal distribution function, right? How we actually use these functions. Okay, so just remember, right? So we have this R binom, right, or R norm, right? Instead of binom, we'll have R norm, which will use to generate a normal distribution, right? So if you want a set of values that that are normally distributed, you'll use this R norm function. If you want to use this D norm, right, so that will give you the probability density function. The P norm will give you the cumulative distribution function, and the Q norm will give you the value of a quantile, right? So that's something we'll use. Okay, so with that, I'll first illustrate the basic programming in R, right? How do you use these logical operators, and then we'll talk about how we can use these statistical distributions, right? Again, with one example. So let's now move on to the hands-on part, right? So we have R installed, right? So we have seen this before. So here is the console where we'll actually do we'll write the code, and we'll see how these functions will work. Okay, so if we start with the if function, right? So let's say we want to define this. So we are assigning 2 values, right? And maybe we can say okay, so here is the if function. So we have assigned 2 variables, x1 and x4. x1 equals to 3, x4 equals to 5. Within this if function, right, we are defining, right, we are testing for certain criteria, and we are using this logical AND. Okay, so if x1 greater than 2 and x4 less than 10, right, we are imposing these conditions, do something, right? So what we can do a lot of things, right? So here we can say we can take sum, right? So or maybe we can say we can calculate a value, which value is, let's say, x4 to the power x1. Okay, and then we can say print this value, and then we end this if function. Okay, so this is how the whole thing will work. So you need these brackets here, right? So you define the condition, and here we are also using the logical AND function, and then we can use this, we'll have to use these brackets, and within the bracket we can execute certain things, right? We can do something. Okay, that's the structure, right? We impose a condition. If that condition is fulfilled, we execute something, and then we can print if we want, or we can do something, right? We can even generate a plot if we want, right? So those kind of things we can do, and then we close the bracket, right? Okay, so you can see this, right? So these conditions are satisfied, so then you will go and do this calculation. Okay, but sometimes these conditions might not be satisfied, right? So in that case we have the else function, right? So that's how the if else function comes. Okay, so the next one that I'll describe is the for function and then the while function. Okay, so for function requires a counter, right? So when you use a counter is something like this. Let's say for I in 1 to 10, right? So when I say 1:10, that means this counter runs from 1 to 10, right? So I will start with 1 and it will go up to 10. Okay, and again the bracket, and inside this counter, inside this for function, we can execute something, right? So what we can execute, let's say we can say print I, very simple one, right? Or yeah, print I is a very simple one, right? We can do a lot more complex things as well, right? But I just want to illustrate, right, how the data structure looks like, right? So here it's just simply printing, right? Print I. Okay, you can write many more complex functions, right? So you can say you take square, right? Print square. You say 10 to the power I, right? And print. Okay, so here you can calculate 10 to the power I as well, right? So here is something that will calculate this 10 to the power, right? Starting from 10 to the power 1, 10 to the power 2, etc., etc. Right? So this is how the for function works. The while function also is a loop, right? So for is a loop, right? It will loop through 1 to 10, right? That's how we define. For while we can take very similar example, right? We can start with one value. We can define while I less than 10, right? And we can take, let's say, log I, let's say. Okay, so here inside the while loop we are doing the log I, and we are okay, sorry. So one of the things we need to do when we are defining a while loop is we have to increase the counter, which we have not. So what is happening is it's actually running an infinite loop. Okay, so this is something that you need to remember very, very carefully. When you are writing a while loop, you need to also increase the I, right, value of I, otherwise I will always remain at 1. Okay, so I'll have to close this now, and I have to restart this. Okay, so it's just simply running through the infinite loop. Okay, so this is something that you need to remember when you are using while loop. Okay, so I'll run this again while I less than 10. So let's put this condition first, right? I equals to I plus 1. So we are increasing the value of I. Once we reach 10, it will quit from this loop. Otherwise, it will simply keep on going through the infinite loop. Okay, so we have the same function as before. We are calculating the log, and then we have the I equals to I plus 1. This is the counter, right? In for loop, this counter was already there. In while loop, you have to put this counter yourself. Okay, so now see, right, we have this log value, right? So we are calculating this I, right, and we are calculating the value from I equals to 2, right? We have put the counter from here, right? We have first increasing the value of I, then we are taking the log, right? So you can do this in different way. You can keep the counter at the end, so you'll start calculating from 1. Okay, so we have now seen how these methods work, right? So again, this is in relation to very simple data, but you can imagine that this you can apply to much more complex data sets. Sometimes we don't, for while we also can use like a true false scenario, right? As long as something is true, right? So we can simply say, for example, while I equals to something, right? Maybe or some value is something equals to true, right? We can keep on running this while loop. Okay, so that is also possible. Okay, so we have seen this if function, we have seen for loop, while loop, and we have also seen how you apply this logical and similarly we can also apply logical or, right? If one of them is true, it will execute something. The other thing I wanted to show you is the function, right? How do you write a function? This is something it will be very, very useful when you write your own function to process your own data, right? So in R it's very simple, right? So for example, we can define a function called square, right? Or squared maybe, right? And what we have to do is say it's a function and x. Okay, so x means it's an input to this function. The function name is squared, right? And what it will do, it will just simply calculate x to the power 2. Okay, and then it will print the value, and that's the function. Okay, it's a simple function, but as I told you, right, you can define very complex operations inside these brackets, right, where we are actually doing this value equals to x to the power 2, right? You can define very, very complex functions. You can add plots, etc. You can do a lot of things in here. Okay, so we are printing these values, right? Now what you can do, we can call this function now. Okay, so we can say square 2. Okay, so you get 2 to the power 2, which is 4, right? Similarly, you can say square 10. Right. So what happens now is you can call this function, right? As I said, this can be very, very complex functions. If you have to process your data through the same steps, you don't want to write this function, right? You can do the same thing 100 times. Instead you call this function. Okay, so I'll just illustrate. For example, if we want is for now I in 1 to 10, we want to calculate square of all these numbers, right? So what I'll do is, instead of writing that function, right, I'll just call squared I. Okay, and you can see, right, for 1 to 10 you will get all the values, right? So this is how you can make your code compact, right? Your program could be very, very compact. Okay, so this is a very useful kind of application of these functions, right? And as I said, for biological data, big biological data sets where you have multiple samples which will be processed through the same pipeline, you can simply define a function for that pipeline and say process all the samples through that pipeline, right? You don't want to write that complex code for every sample, right? And that's how your code will be very compact. Okay, so this is the very basic part of programming that will be useful for you in this course, and we'll use some of this later on. The other part that I wanted to talk about is the statistical functions. Okay, so there are 4 functions that I mentioned very briefly, right? So one is the so going back to the presentation, so you have this R, D, P and Q, right? So these are the 4 functions that will be useful for us, right? So let's say we want to generate a normally distributed function values, right? Normal distribution or values that are normally distributed. Okay, so we can say define a variable, assign a variable, this R norm. Okay, what you need is how many values should you have in that distribution. So here we are saying, for example, n equals to 1000, so we should have 1000 values, but you can change this number. You have to say what should be the mean of that distribution and what should be the standard deviation. Okay, so mean equals to 0 and standard deviation equals to 1, right? So we are generating a standard normal distribution with 1000 values. Okay, and this is generated. Now how do you look into these values? You can say, okay, head value, right? If you now just type value, you will get 1000 values, right? So the first thing we can do is we can say head value, so it will show you first 6 values, right? So these are the first 6 values there of that standard normal distribution. If you want, let's say first 10, you can say head value comma 10. Okay, so this is the notation, so it will tell you first 10 values. You can look at the last 10 values, right, using the command tail. Okay, so again last 10 values that will be shown to you. Now these values do not mean anything, right? So okay, these are part of standard normal distribution. Can we see whether this is a standard normal distribution, whether it's a normal distribution at all, right? So you know the shape of a normal distribution, right? So can we see whether we are getting a normal distribution? So for doing that, we can use very basic visualization techniques, right? So one of them is called the histogram. Okay, so histogram we can generate with this. Okay, I'll just start with a very simple function. Okay, and the moment you give this histogram value, right, value contains all the values, right, these 1000 values in there, right? So it's a vector, and you see that this is the distribution that has been generated. So your y-axis is frequency and x-axis is the value, and as you can see, right, this is a normal distribution. It looks like a normal distribution, right, and mean close to 0. Okay, so that's likely to be a standard normal distribution. Okay, all right. So this is one of the simplest visualizations. We can have much more complex. We can change these to much more complex. We can change the colors, etc., which we will talk about a bit later when we talk about basic visualization techniques. Okay, so this will come later on. Okay, so we can now move on to the next function, right? So to close this plot, right, the command is tape.off, so it will remove this plot here. Okay, so moving on to the next commands, right? So we have this dnorm. So you can also find out, right? So you might ask, like, how do you know that we need to give this n and mean and st? So you can actually find this out by just writing this. Okay, so if you write the function, for example, rnorm, it will tell you what are the values that you have to supply. Okay, so you can see this is a function, right? This is a function that has been written in R already, right? Like our function, right, that we wrote, where we are passing only one value. Here you can pass multiple values, right? So here function rnorm will take n, the number, right, and here is the mean and the st values you have to give. Okay, and similarly for dnorm, right, you have to give this x value, right? So as you can probably see, right, dnorm will give you the probability density, right? So dnorm, so we have to give that value x and say, okay, the mean and st. Okay, so value x is, let's say, value of 1 point, right, and if we are working with this mean st1, okay, so it gives us the probability density function. Okay, what is the probability that you will get the value 1? Okay, the next one, right, this pnorm function will give us the cumulative distribution function. Okay, and again as before, I'll just write pnorm. Okay, you can see there are a few things, extra things in there, right? So pnorm is will give you the probability density function, right? So here you need to give q a value, you have to give a mean, right, and then you have to give the st value, and then you can tell lower tail or upper tail, right. So that is something you have to mention, right. And so if you remember cumulative distribution function, right, so when you say lower tail equals to, so lower tail equals to true, right, it will give you like what is the probability in the lower part, right, what is the probability that values below that, right. But if you want to get a probability for values above your target value, then you need to give lower tail equals to false, okay. So for this part, let's say we write u mean equals to 0, equals to 1, okay. So I'll just keep the default value lower tail equals to 2. So these values are the default values of this function. If you want to change, you can change, okay. And it's saying 0.84, okay, right. So you can also try it other functions, right, and you can also try the lower tail equals to false, right. So it will give you the values, what is the probability that values will be above this 1.5, right. So this is 0.066, right. So as you can see, right, these two sum of these two values should be 1, right, the lower part of the distribution and the upper part, right. Below 1.5, what is the probability, right, the cumulative function is 0.93, and above 1.5 it's 0.0668, okay. So this is how the p-norm function works, and the other function that we have is the q-norm function. As before, we have again, right. So here we are saying the q-norm, right. This is a function. You have to give the values p. You have to give mean value, you have to give SD, and you have to tell whether lower tail equals to true or etc., right. So the default is lower tail equals to true, right. So we'll see what happens if you say lower tail equals to false, right. So here let's say we want to know the value at the 95% quantile, right. So at the 95% of the distribution, okay, what is the value at 95%, okay. So q norm, we have to say 0.95, mean equals to 61, okay. This is the value 1.64, okay. So if you do this lower tail equals to false, right, so it will actually give you the 5%, right, at the lower part, right. So you have these options, right. If you want to 5%, we can check whether 5% is the same, right. So you see this q norm 0.05 will give you the same value, right. So if you use lower tail equals to false, so we rarely use this lower tail equals to false with the q norm function, because we can access this 5% value or the 95% value, right, with this q norm function itself. So we don't need the lower tail function. For the other function, for the cumulative distribution function, which is the p-norm function, we need this, we can use this lower tail and lower tail equals to true or false. That becomes very useful when you want to know the cumulative probability, right. So you want to know what is the probability that values will be less than that value or values will be above that value, right. So we have now illustrated these four functions for accessing statistical distributions. These are exactly similar, right. The idea are very similar for other distributions, for example Poisson distributions or binomial distributions. You can again check the requirements, the parameters will be different, so you can again check what are the parameters that you need, right. So these are related to the specific probability distributions that we use, right. So for binomial distributions you have to give the probabilities, etc., size, etc., right. So for Poisson, right, so you have to give the rate parameter lambda, right. So these are dependent on the parameters of the distribution, right. So again, but the functions, this q function, p function, r function, these remain the same, their idea remain the same. Okay, so we have looked into these statistical distributions. We have seen how we can access these different functions and how we can utilize these functions. This is something that will be very useful for statistical analysis. If you want to access certain functions, we want to calculate certain probabilities, and we now have an understanding, right, what these functions do. We have seen hands-on what do these functions do, right? We have illustrated that. Okay, so we have covered these two parts. So what I'll do is, like, we want to summarize, right? So we have looked into basic programming in R. We have talked about logical operators, right, and logical and logical OR. We have looked into if, how to write an if code, right, how to implement if. This is something very, very useful. You will see later on for statistical analysis, for visualization. These if functions will be there, and the logical operators will be there, right? When you want to plot certain different parts of the data, those will be there. So we have also talked about the for loop, while loop, and we have seen how we can implement a function. This is something that again will be useful if you are working with big chunk of or multiple samples of big data sets, and you want to process them in similar pipeline. So this is something that would be very useful. Of course, we have whatever we have talked about is very, very basic, and beyond this we have a lot more programming, right, advanced programming in R that you can do. And the second part, we talked about statistical distributions in R, and we have looked into how we apply different functions and how you access these different statistical distributions, and you generate some of the statistical kind of distributions, right, and using the R norm or R binomial functions. Thank you.